So I'm going to go ahead and read this problem. I have an arch in the form of a semi-ellipse. Is 52 feet wide at the base and has a height of 20 feet. 12-foot tall truck wants to pass through the archway. How wide can the truck be? So the answer to this winds up being like super large, but I guess we're just talking about an overly wide truck with something very, very big on it. So just, we got a big truck. Anyway, so I've got this half ellipse, so I'm actually going to, this graph doesn't really, I don't need it for accuracy or anything like that, but I'm going to draw a half ellipse there. I'm going to make it 52 feet wide, or I'm going to mark it 52 feet wide, and I'm going to mark it 20 feet tall. So I'm going to go like that. I don't ever care about, or in terms of the equations of these things, specifically how fully wide. I only want to know the halfway, because that's going to be my A or my B value. So I know that's 26, and I get that from taking half of my 52. And I know that this distance here is 20, because it's 20 feet at its highest point. So I basically want to fit a truck in, like this, boink, boink, so that this height is 12. How wide can the truck be? So you can see that it's probably going to be pretty wide. Like, it's going to be significantly more wide than it is tall. Maybe we could add a restriction that it can't cross the center line, or that it needs a foot of clearance from the center line, or something like that. But anyway, just for the context of this problem, what it's asking, how wide can it be if it uses the whole width? So what I'm going to do is figure out an equation of this thing, the green part there. So I know that x squared over 26 squared plus y, make that look like 6, squared over, and I'm just letting the origin be that centerpiece because that makes it easiest to work with, over 20 squared has to be equal to 1. Well, I square those guys out. I get x squared over 676 plus y squared over 400 is equal to 1. So now what I need to do is figure out the width at that point. If I have the width at that point right there, then I know, or if I have the x value, that is x comma y, right? So I know that the y value for here is 12, because that's how high off of the origin, or off of the x-axis it is. If I have the x value, that's my question mark, then what that gives me is this length, which is half of the width that my truck can be. Once I get the x value, I just double it. So, what I do now is I plug in this 12 for y right there, and then I solve for the x. And then I have my unknown x value. So I get x squared over 676 equals, what's that come out to be? 144 over 400. And that's, oops, undo, wait, I'll just erase. That's a plus, not an equals. So what I'm going to do now is subtract the 144 over 400 from 1. And what that gives me is x squared over 676 equals 256 over 400. You could totally have that number. You could have a different number. You could have a decimal. You can make a calculator do this work. Whatever. What I just did was I treated the 1 as 400 over 400, subtracted this, so I subtract 144 from 400 over 400. I got 256 over 400. Whatever. If you want to use a calculator, do it. Anyway, now I can cross multiply this thing. Actually, I'm just going to multiply both sides by the 676, which gives me that x squared equals 256 over 400 times 676. So I go ahead and I square root that number, and I get x equals 20.8. Now, what that is this length. It's half of the width of that blue box right there. So what I need to do, it asks how wide can the truck be. I gotta double that. So, according to this setup, the truck can be, I double the 20.8, get 41.6 feet wide. Not that bad.